Good morning, everyone, and welcome to what I hope is the first in a long series of CAD tutorials. My goal here is to try to break it down, make it easily accessible to everyone. So do me a favor, subscribe to the channel, like the video, comment below, comment especially if there's something that you want to learn how to do in CAD, and I will try to do a video on it and make it easy for you. Now I use Rhino 3D for my programming. I've had it forever. There's other software available. I've got Fusion or Libra on my computer as well. I've also got SolidWorks that I barely use. Most of my stuff's in Rhino, but I can do stuff on other software down the road if it's so desired. I figured we'd start with a simple tab. This could be a tab for anything. Say it's a shock tab. We're going to start with our center hole, work our way out. It's a good idea to double check that you've got it on diameter and not radius. I wanted a 1/2 inch diameter. I had the circle tool set to radius. Double checked my dimension, it was twice as big. So start the point again, set it to diameter, 1/2 inch. And we're going to set the outside of the tab where you want a 1.5 inch circle where the bushing would sit, say for a shock. Double check the measurements. Again, it's one of those things that's handy to do once in a while. No matter how long you do this, it tends to get monotonous sometimes and you miss it. I'm going to draw out a line here, and we're just going to draw out a line, straight line. Doesn't matter where it is on the screen. We can select a line, select move, and we move from the center of the line to the center of our hole, and then we can move it down. So I want to move it down 3 inches. Type move, hit enter, start point, 3 inch, pull down, click it. From there, we can click a line from the end of the line, and we don't want the center that it snaps to, we don't want the end, we want it on tangent. Select our line there, use the mirror command, mirror off the center of our line, which came from the center of our circle. We can now select everything, grab the trim tool, and cut the center out, and just that quick. We have a shock tab now. If I'm not trying to show people stuff, this is about twice as fast. This is one of those things that I've been told I designed them wrong, but I promise you this has been working for me for more than 15 years. This will cut on a plasma table just fine. Now, let's say we have this tab and we want a little bit more style. Nothing's faster than a hole. So we grab the offset command and we offset this tab in 1/2 inch. But if you can see, obviously that 1/2 inch in includes our hole, so we built another circle to give us our bushing space. Grab that circle, the offset dimension there, trim tool to remove it. We've got a windowed tab now. And if we go over to our fillet corner tool, we can set a radius, fillet the corners, and it looks like a finished tab. Imagine this is something that would take forever on a grinder or a mill or whatever. We can program these tabs in 2 minutes flat. And we can shape them to whatever you want. It doesn't have to be centered. You can put that line anywhere you want. And I'll show you some template stuff later on here. So let's make another shock tab. This time, we're going to make one that sits on a tube. So same as we did last time, 1/2 inch bolt hole, 1.5 inch circle for where the bushing would sit. We're going to set a 1 3/4 inch tube to represent, say, a piece of DOM, a shock tube or shock hoop, something like that. And we're going to move that from the top of the circle to the center of the bolt hole, because our shock tab dimensions are always going to be from mounting surface to the center of the hole. Move it down 2.5 inches. Now, let's say we're not putting it on a shock hoop. We're not putting it on a piece of tubing. We want to put it on an axle. So let's set a 3 inch circle. Take that same circle and we're going to move it from the top of that one to the top of the other one. That sets us off 2.5 inches. We'll get rid of this other circle here. And we're going to go over and pick our line tool. And from the line tool, we're going to take from the left edge up to the tangent. We use tangent because that's the one that flows properly over the circle. It's just one complete line. We're going to use the mirror tool, select everything, back to the trim again, and we're going to cut off all of the stuff on the bottom here, cut off the intersecting lines that we don't need, cut out the radius from around the bushing, and go grab the fillet tool. Now, I originally set this to a 1/4 inch. Quarter was just too much visually, so we're going to undo that, and we're going to grab the fillet tool again, and this time set it to 1/8 of an inch, 0.125, and fillet both of those corners. And just that quick, we have a complete shock tube or shock tab ready to go onto an axle tube. You can send that file out and have it cut, no problem. So let's try something a little bit different here. How about a 3-bolt exhaust flange, say like a header flange. Start with a 2.5 inch circle here. And our bolt holes are going to be 3/8 bolt holes, 0.375. You know, knowing fractions over to decimals is handy because we all work in SAE up here. Now, this one, we're just going to set it up kind of random. Let's say we're making a tube to connect 2 pieces of pipe. We have no set dimensions. I like to grab the upper hole, set it on the edge, move it up, say a 3-inch hole, 3/8 hole, usually 1/2 inch up. Now, what I've done here is I've actually made a hex to simulate the nut or the bolt head. Select that hex, 6-sided shape, and I scaled it to 9/16 of an inch. Now, that's what the bolt head on a 3/8 bolt is going to be. I click move and move it from the center. Accidentally move it to the wrong place there, but move it from the center there to the center of the hole. And we can see there's still plenty of clearance for that to spin around. We can get a wrench, should be able to get the box end on that even. I mean, yeah, there's about 3/16 of an inch. Should be enough to get a box end wrench around that nut if we ignore the weld, or an open end and still have room for weld. So outside of that, just grabbing a circle and tool, and from the center of the bolt hole, run it out to our center flange. Aesthetically, it's just something that I tend to do a lot. That 1-inch circle seems to fit pretty good. And we're going to use polar array. Now, I use this tool so much for repeating patterns around a center point. We select 3 as our units. Our degrees are 360 degrees. You can literally click the enter key twice and it sends it around the circle. Now, if we draw a straight line from our outside circle to our outside circle, we can see that it's not really giving us a flange. It's going to hit our tube. So we need something bigger than that. So we're going to offset that center by 1/2 inch. I wouldn't want to go any less than that. And I mean, this is just for demonstration purposes, how quick and easy it is to make a flange like this. So we've got 1/2 inch of material all the way around. We're going to select our flange and the 3 circles that go around our bolt holes, and right back to the trim tool. You're going to find you use the trim tool a whole lot. I use that command more than just about anything. We can go in, remove all of these, and go back to the fillet tool. I wonder how that's pronounced all over the world. But use the fillet tool, and you know, since this flange is just being made out of nothing, the radius on the fillet doesn't really matter. This is more aesthetics and a little bit of strength. Going around and selecting each one, and just that quick. I mean, we're 2-3 minutes and we've got a flange. You could burn out a dozen of these and have flanges for your entire car. It's not a big deal. Now, that's one way to do it. A reminder that, you know, go in and join all of your lines afterwards. Another way to do it is we want our outside dimension. Instead of using our center hole like that, we'll grab those bolt holes. You already saw how to do that. And from there, we just literally draw a line from center of bolt hole to center of bolt hole, back to center of bolt hole. And we can grab that triangle now, click offset. Now, obviously that 1/2 inch offset was just not enough. It's hitting there. So we need to offset it a little bit more. Click the offset tool. Now we've got, you know, instead of that 1/2 inch being on the circle, we've now got an inch offset. That gives us a 1/2 inch of meat, same as the other flange. We know that we have a 1 inch radius around those bolt holes. So if we take the fillet tool and we set our radius to 1 inch, it's going to give us a consistent circle all the way around that bolt hole. You can see how at any point around that bolt hole, it has the exact same amount of meat all the way around it on the outside. And I mean, that's two different ways to build a flange, two different aesthetics. They both work. And I mean, if you don't like how beefy that is, we just grab the outer ring, click offset again, and pull it in. And just like that, I can offset it a 1/4 inch, and it's a completely different bracket with a 5-second command. Super handy. Now let's take a different approach. There's pretty much, you know, 2 ways to measure the bolt patterns, and we got to worry about the center dimension. Now, on say a 3-bolt flange, that's what we're talking about here, but it doesn't matter if it was 3-bolt, 5-bolt, 8-bolt. It would be just like a bolt pattern on a car, say 3 on 3.5 inch. So if we set our 2.5 inch center hole for our exhaust, we put a 3.5 inch circle. If we click the top of that circle, we could click anywhere on that outer circle, put a 3/8 bolt, and we know that if we do the polar array command, we end up with 3 bolt holes that are on the 3.5, just like your axle bolt pattern. If we did this 5 on 4.5, you could make a 1/4 inch wheel spacer just that easily. On a 1/4 inch wheel spacer, you set your center hole, you set your outer size, and you set your bolt pattern holes. There's no trimming, no nothing. It's an inner circle and outer circle and 5 holes in the middle of it, and you could make a wheel spacer. Now, all of this is the exact same as what we just did on the other flange. The difference being we based our bolt pattern off a 3 on 3.5 bolt pattern. I'm just finishing out the flange for the sake of argument. All the same commands all over again. We use the fillet tool and we go back in and we fillet every corner again. You know, repeatability here. This is something that took forever for me to figure out. If it's something you're playing with, mess with these commands. I mean, worst case, don't save your file, delete it, start from scratch again. You know, this is the beauty of the software, is we can take a look at this and go, I'm not quite happy with it. Now, if you don't have the bolt pattern, since we know that a flange like this is symmetrical, we can measure bolt hole to bolt hole. So if we take our center hole, our 2.5 inch exhaust, and we're going to go back to our shape tool and change the sides from 6 to 3. Now, with the 3 sides, we can scale this, and if we scale from point to point and make that measurement, say, oh, what did I change this to? 3.5 inch? You know, let's say it was 3.5 inch. That was the number we were given. We can move that triangle from the center of the triangle to the center of the circle, and our bolt pattern is now situated. This is the beauty of it. Now, all we have to do is grab our circle tool, and you can see all 3 sides the same. Our circle tool, and put our 3/8 bolt holes here. I mean, maybe it's a 1/2 inch bolt hole. This is all something you can lay out. It's just a couple of keystrokes away. But now, instead of using the polar array, we've used this tool here because we had our dimension from bolt hole to bolt hole. Once we've done that, the commands are just as easy again. Instead of using array, we're just going to put circles from the center out of each of those. We're going to run a circle from the center out to the center of the bolt hole. For no other reason than that's what I tend to do when I'm designing them this way. You find that once you start programming it, you get into kind of a mental muscle memory. You'll do the same thing over and over again. Your tabs will turn out the same. You'll round corners at the same radiuses. I have files upon files upon files upon files. Most of the time I used to redraw brackets instead of reusing what I already had. And I'd still find that they'd be almost the same every time because that's just what I did. And of course, as I'm talking, I forget to fillet the one edge there. But now, once again, two different ways to get specific bolt sizes. Now, let's get to something a little bit more relatable. Let's say you're making a frame template here. Cardboard template, we've all done this because we make a template. Now, once we've got it, I'm going to show you a couple of ways to lay this out. I mentioned this in my frame video, and this is why I brought it up, is that, locating areas with circles. So we've drawn our first line, and you can see on the drawing there, I've got straight lines. I've got some lines that are parallel there. We're working with circles. Our diagonal lines, if we start from a point and use radius instead of diameter, and since we know that the radius is from the center out, when these circles cross, that's the point for the next line. So we only have to start with one line and a whole lot of measurements. And we can start to lay out this entire thing here. Now, if you look at my drawing, you can see this bottom left corner, the upper and lower rail is parallel. So I measured that with the tape measure already. That's why all the Sharpies there. Now, on those inside or outside corners that are radius, the thing here is that you need to continue the straight lines to find your point. I did that, which means that I knew where they were. It was as simple as on the inside corners, just continuing the Sharpie over. On the outside corners, I literally laid it over a piece of paper, drew my lines, and measured point to point. Now, literally, over and over again, all I'm doing here is I'm going back to my drawing. I'm starting from one point to another point, and I'm using my circle command on radius. And that's going, if we're starting from a known point, and we have two dimensions giving us two radiuses we can use, we already know that it can only land in one spot in space. That's why you see it cross. Well, it can land in two. The circles will cross over in two spots. If your circles don't cross over, then they don't meet each other. So we can literally go across the drawing here, and starting at one corner, we can work our way out. We know that this rail here that I'm working on is parallel to the other, but if you look at the measurement, it's 1/8 of an inch longer. So all I did was copy that line from the bottom point, copy it up to the next point, turned on the control points for that line, and I stretched it out by 1/8 of an inch. And by doing that, that line's now 8 1/4. This line is 8 1/8. And they're parallel because those lines are already parallel. And we're already more than halfway through this template. It happens so fast. But again, from that very top point, you can use the measurement across the top, use our radius command, use our radius from the lower one here, and this is giving us our line across the bottom. We're just going to keep repeating this. Now, we can't use, this is, we're not measuring angles here. We don't have to look at angles. We're not even using them. This is beautiful because the better your tape measure is, the more accurate your template's going to be. Now, with lots of straight lines, this is amazing. I mean, I can guarantee that what I'm programming here is more accurate than the next method that I'm going to show you, but this relies on a whole lot of straight lines or known radiuses. I mean, you can only do so much. On a frame template like this, it works pretty good, but it is limited. Now, you can see I'm checking this measurement here. Up on my page, it said 3 inches. We're just over 3 1/8. Sloppy tape measure, as we multiply across, if the measurements are probably a whole lot closer on the left side than they are on the right, by the time we get to the right side. But I have 26 inches from that point to that point on my template, and you can see across those 28 inches or 26 inches, I am out by 0.1 inch over that entire lot. Now, this works well, but if you've got a lot of complex curves, we still need to do the radiuses on that with the fillet tool. This is the method that I generally use. If all I got to do is scan in a picture. So the very first picture I showed you, we're going to drop that as a background bitmap, and we're going to scale it. And scaling from the bottom corner, the furthest dimension possible. Now, I'm going to say something right now. This picture, you can see that my template is not perfectly flat. You can see it. When I did my measurements, it was flat on the floor. Looking at this it's sitting up on my thermostat. That was the best light I could find. This method relies on your template being as flat as possible and your camera being flat and square. You look down the street. If you're looking down the street, your street tapers off to a point. It's perspective. Now, if your camera's on an angle, it's obviously not that amplified, but your measurements will change. You want your picture taken as square as possible. And we can literally, at this point, trace lines over top of this template. If my picture is bang on, then my programming is going to be bang on. Now in this case, I can literally use straight lines. I'm going to drag straight lines all over this thing. But you can see, even by the shadow on the wall here, this corner that I happen to just zoom in on, you can see that it's farther out from the wall. It's pulled towards us. I already know that this is going to be off in the top right corner. I know that because the picture's not square. I usually take them on concrete floors, as little background as possible, stark contrast because we want sharp lines like we have here, but weigh it down with something. Put a paint can on it, put some sockets on it. A lot of the times I'll even take a picture with a tape measure in the picture. So if someone's emailing me a template, I can literally lay a tape measure in it. I can scale it to the tape measure because that's a known value. And I don't even need, I don't need any measurements. I've got it all in front of me. Now, it always involves a little bit of grinding doing it this way, but you can see how quickly I can program that. Now, the straight line tools are all right. But here's the thing. This was a faster method than using the circles. But if we look here, you can see the top right section where the template is curled and pulled away. You can see where it's squatted down. The left is almost identical. The up angles are almost the same, but that top right corner, right where that template is bowed out in the picture, you can see the differences. If that template had been perfectly flat to the wall and my picture was perfect, yes, I recorded the video and I'm doing the voiceover now. I kind of got to change it. But the beauty is that I can show you why it didn't work and tell you how to fix it. If you had made your template different or taken your picture, if I had taken my picture differently, the template would fit better. So change the radius on this and we can just show you here. You already saw the comparison. But like I said, the bottom left, the middle where the template's flat on the wall, it fits well. The top right corner doesn't fit so well. Now, the most common tool I use is the curved line tool. I know there's a technical name for it, but instead of straight lines, it draws curves. So all you do is drop control points along the way and it will fold to your shape. So my ends are straight lines here. I'm setting those because they've got 90-degree corners on the end and gives us a point to work off to. I take my curve line tool and I'm just drawing the straight line. When it starts to curve, that's my first control point. This is something you get to figure out by feel. Now, I'm dropping control points along the curve and literally until it looks right, but that's one side done. No trimming, no nothing, it's just done. Same command on this side. We're going to drop a few control points around here. I'm not quite lined up with my curve. It's not super good on that part. I know that, and the thing is with this is that once you've got this line all drawn, once I've got this line all drawn in this case, we can select this line again, and we can go back and we can drag these control points around. We just select that point and we drag it around. And you can see that by moving one point, it actually moves the line for more than just in between points. It works like, if you were to move an old meter stick, it flexes and it causes a flex on the other end. Now, if we compare that to what we had going on before, I mean, we already know how it's going to line up because we've already drawn it. We've got the two of them that we drew over top that are almost identical, except that I hadn't radiused one, but with the curved line tool, we didn't need to radius it. And then compare it to the other one, and, again, this is the template lacking, where it pulled off the wall, the top of the template dropped down, and you can see that where the bottom of the line there is good, but the top of it is too narrow. It just doesn't work. So that's where I'm going to leave it off today. I hope that I crammed a whole lot of information into here. Do me a favor, if you haven't already, subscribe to the channel, like the video, leave me a comment, tell me if it helped or not. If there's something you want to see, tell me that. I want to make CAD videos pointing out things that help people. I'm going to try and drop one of these videos every Monday, and we'll catch you on the next one.